Well, here we are with 7E part 3, and we're doing number 10. And so in a certain lottery, 3 different numbers between 1 and 8 inclusive are drawn. These are the winning numbers. How many different selections are possible? And assume that the order in which the numbers are drawn is unimportant. Well, we're talking combinations then, and that's going to be 8 factorial over in the difference between 8 and 3 is 5. So 5 factorial times 3 factorial. And now 8 factorial is 8 times 7 times 6 times 5 factorial. Look at that. The 5 factorials divide out. 3 times 2 is 6, so the 6's divide out, and we just get 56, which is selection B. Now for 11, a pollster wants to minimize the effect the order of the questions has on a person's response to a survey. How many different surveys are required to cover all possible arrangements if there are 8 questions on the survey? Well, how many how many options do we have for the first question? We have 8. Once we choose one, we have 7 left. Once we choose one for that, we have 6 left, and so on. So we're talking about 8 factorial. And consequently, 8 factorial is 40,320, and that is selection A. And those are all the possible arrangements of those 8 questions on the survey. 40,320. For 12, how many 6-digit numbers can be formed by using the digits 0, 1, 2, all the way through 9, if repetition of digits is allowed? Well, how many ways are there to choose the first digit? Well, there's 10. How many ways are there to choose the second digit? Well, there's 10 again, and so on. And we're going to choose 6 digits in all, so that's going to be 10 to the 6, which is 1 million, and that's choice A. Finally, 13, we simply have to evaluate the factorial. 6 factorial over 4 factorial. Well, 6 factorial is 6 times 5 times 4 factorial, and in the denominator we have 4 factorial. They divide out, and 6 times 5 is 30, and that is selection A. And we're done.